A black hole is not a hole, and almost nothing you have been told about it is right. It is not a vacuum cleaner. It does not suck things in. Swap the sun for a black hole of the same mass, and the Earth would keep orbiting exactly as it does. Guess what would actually happen to us? It would get dark and cold. That is the entire list. So if it does not pull harder than anything else, what makes it different? There is a line around it, and what happens at that line is genuinely strange. Start with something ordinary, because the idea comes from a completely ordinary place. Throw a ball upwards and it comes back. Throw it faster and it goes higher. Throw it fast enough and it never comes back at all. That speed has a name. For Earth, it is about 11 kilometers a second. For the Moon, it is much less. Guess what the number depends on? How much mass is underneath you and how close to the middle of it you are standing. So squeeze the same mass into a smaller ball and the number climbs. Keep squeezing and eventually that number reaches the speed of light, and nothing goes faster than light. That is the whole idea. There is nothing more to it. The place where that happens is called the event horizon, and the name is doing a lot of work. It is not a thing. There is nothing there to touch. It is a boundary in the map, not an object on the ground. Guess what you would feel as you crossed it? Nothing at all. For a large enough one, no bump, no warning, no sensation. You would cross it without knowing, and only afterwards would it matter. The most important line in physics is one you cannot see and cannot feel, which is why calling it a surface has confused people for a century. People repeat the next part without understanding it, so it is worth going slowly. Outside, you can move in any direction in space, but only forwards in time. You can stand still. You cannot stand still in time. It carries you. Inside the horizon, those two swap over. Guess what that means for a person falling in? The center stops being a place. It becomes a moment in their future. You cannot steer away from it for the same reason you cannot steer away from tomorrow. Firing your engines does not help. It is not a direction. It is a date. That is what the boundary really is. It is where away stops existing. Two honest observers watching the same fall disagree completely, and both are right. The person falling in crosses the line and keeps going. It takes them a finite time. From far away, watching them, you see something else completely. Guess what you see? They slow down. Their light reddens and dims. They freeze just above the line. And they stay frozen, fading, forever. You never see them cross. Both descriptions are correct. Neither one is an illusion. There is no view from nowhere that settles it. Time is not a shared clock. That is not a paradox to be solved. It is the actual answer. The strangest fact about the darkest object anybody has named is how bright it is. Gas falling towards one does not drop straight in. It goes into orbit first. It piles up into a flat disk, and the inner parts move faster than the outer parts. Guess what happens when layers of gas rub against each other at those speeds? Friction, enormous, ridiculous amounts of it. The gas heats to millions of degrees. So the region around the darkest object in existence becomes one of the brightest. The light we see from them is never the object. It is the cue outside. Some of these are visible across the entire universe, and they are just traffic. All of this sounds exotic, which makes the next number harder to accept. Almost every large galaxy has one at the center, including ours. Ours has a mass of about 4 million suns, sitting in a region smaller than our solar system. Guess how we know it is there, given that it emits nothing? We watched stars orbit an empty spot for decades and worked backwards. That measurement took most of a career, and it is one of the most patient things science has done. Nobody photographed it. They watched what moved around it and refused to guess, which is a better description of how real knowledge gets made than any story about Eureka. The ending of the story is the part almost nobody expects. They are not permanent. They leak extremely slowly, and eventually they evaporate. The bigger it is, the slower it goes. The ones we know about will outlast the stars. Guess how long the largest ones have? Longer than the age of the universe, multiplied by numbers with 100 zeros. So on any human scale, they are forever. On the universe's own scale, they are temporary. The last black hole will finish evaporating long after the last star has gone out, and when it does, the universe will be dark, cold, and completely empty. One thing here is worth carrying around, and it is not about space. Every single thing here came from taking one ordinary idea seriously to the end. Escape velocity is taught to 15-year-olds. Nothing exotic was added to it. Guess where the strangeness came from? From refusing to stop at the point where the answer got uncomfortable. The equation said the number reaches the speed of light, and people said that must be a mistake. It was not a mistake. It was the most interesting thing in the sky. Almost every real discovery looks like that from the inside. Somebody follows a boring rule past the point where everyone else assumed it broke, and the universe turns out to have been telling the truth the entire time.